Okay, so I don't know if you caught the end of this from the last video. Sometimes it only does a certain amount of time. So our final answer looks like this. Okay. Okay, let's move on to number 7. Okay, so you pretend it's an equation. You set your denominator equal to 0. And when you do that, you would get -2. So you always, when they're fractions, set denominators equal to 0, any that you see. So we know that's one of the critical values on our number line. Then you need to solve the whole problem as if it's an equation. So if I set x squared plus 2x plus 8 all over x plus 2, and I say is equal to 0, you can put it over 1. When I cross multiply, 0 times x plus 2 is going to be 0. When I cross multiply, x squared plus 2x plus 8 times 1 is just x squared plus 2x plus 8. Okay, is there a combo that multiplies to 8 that adds to 2? So 1 and 8, 2 and 4. Oh wait, that's -8. Okay, let me cross that out. It's -8. So is there a combo that multiplies to -8 that adds to 2? So let's see, 1 and 8, 2 and 4. So maybe let's do 2 and 4. Multiplies to AC, that adds to B. So we know 2 and 4, and we can put a negative on the 2. -2 times 4 is -8, and they add to +2. Okay, so if we set create factors, and if we set our factors equal to 0, we get 2, and we get -4. So those are the critical values. You always set your denominators equal to 0, and you solve, and when you solve, those are also your critical values. So then for this problem, we're going to draw a number line. And I'm going to do my critical values. So I have -4, I have -2, and we have 2. Okay, so like I said, when you have a denominator and you solve, denominators are always going to be open circles no matter the symbol, because you're going to get undefined. And then you plug that number into your inequality. Okay, then for the rest of it, whatever you solve for, you can look at the symbol. So since the symbol is just greater than, we know that the other critical values are also open circles. If it was or equal to, the -4 and 2 would be closed circles. So then we need to test values in different regions. So if I tested, let's say 0, if I put 0 on top, I'd get -8. Over if I put 0 on bottom, I would get 0 plus 2 is 2. So I'd have -4. And is -4 greater than 0? No. So we don't shade that region. Let's say I plug in a number greater than 2, like 3. So up top, 3 squared is 9. 9 plus 3 times 2 is plus 6. So 9 plus 6 is 15. And then if we, so let's see, what do we have? Let's see, we have 3 squared is 9. I have to write this out. 9 plus 2 times 3 is 6. Minus 8. So we have 15 minus 8 is equal to 7. And is 7 greater than 0? Yes, so we shade. Okay, let's plug in a value in here. So let's do -3. So on top, -3 squared would get me 9. 2 times -3 would get me -6 minus 8. Now I know that I'm going to have a negative number. And is the negative number greater than 0? No, so I'm not going to shade in here. Oh wait, I didn't finish that problem. Okay, so let me keep going. So what would I have? So just kidding. So we would have Let's see, 9 minus 6 minus 8. So we would have negative 5. Okay, again, I'm plugging in negative 3. So in the numerator, I have negative 3 squared minus 6 minus 8, which is negative 5, over, if I plug negative 3 in the denominator, negative 3 plus 2 is negative 1. So is 5 greater than 0? Yes. So I actually should shade that region. Sorry about that. Okay, so if I plug in negative 3, top and bottom for the x, it does work. Did I do that for this one? Let me retry 0. Okay, 0. So if I plug 0 in, I would get negative 8. Negative 8 over 2, negative 4. Okay, that doesn't work. If we plug in 3, we would get, in the numerator, I need to retry positive 3. So if I plug in positive 3 up top, I would get 7, but I forgot to plug in 3 in the denominator. So 7 over 0 plus, or 3 plus 2 is 5. Okay, so that's still greater than 0, so we do shade. Okay, now let me plug in negative 5. So on top, let's see, we would have negative 5 squared would get us 25 minus 10 minus 8. And then 25 minus 18 would get us 7 over, if I plug in negative 5 in the denominator, negative 5 plus 2 would get me negative 3. And is this negative number, right? Negative 7/3 greater than 0? No. Okay. So then when I write my answer in interval notation, I would look at this. I move from left to right. So I first start at a circle, open circle at negative 4, comma. I see shading, and then I stop at negative 2, open circle. I don't have shading until another section, so we do union. I see an open circle at 2, and we're heading to positive infinity. Okay, last one. So we need to set our denominator first equal to 0 to find first critical values. So if I set this equal to 0, I would look for combinations that multiply to negative 24, a times c, that add to b, negative 5. So let's see, 124, 2 and 12, 3 and 8, 3 and 8. Okay, it seems like it's going to be something with 3 and 8. So we have negative 8. So 3 times negative 8 is negative 24, and if you add them, you get negative 5. So we have x plus 3, x minus 8, and then we get negative 3 when we solve, and we get 8. So we know that these are some of our targets, right? And then we need to find our other ones by solving. So you can pretend that this is an equal sign, right? And if I put this over 1, if I cross multiply, I would get x plus 6 times 1 is x plus 6, right? 1 times x plus 6. And then if I look along the other side, 0 times any expression would get us 0. So if I distribute, you get x plus 6 is equal to 0. So we get x is equal to negative 6. So that's our other critical value. Set denominators equal to 0, and then we solve, pretend it's an equals. Okay, so now we're going to do our number line. And we need to do our critical value, so I'm going to do 8, negative 3, and negative 6. Remember, always your denominators are going to be open circles. So my values when I set denominator equals 0 were negative 3, open circle, and 8. Then whenever you solve, you can look at the original symbol. So this would greater than or equal to means closed circle. So when I solve, I got negative 6. So I know that's going to be closed circle. Let's test points in all the regions. So between negative 3 and 8, I'll test 0. If I plug 0 into this problem, on top I would get 6. And the denominator would get negative 24. And that's going to be a negative number, right? And is negative greater or equal to 0? No. Nothing in there. Let's say we plug in 9. So if I plug in 9, on top we would have 9 plus 6, we would get 15. Let's see what we'd have in the denominator. So 9 squared would get us 81. And then we have negative 5 times 9 would get us negative 45. Minus 24. And so what would we have? 81 minus 45 minus 24 would get us 12, 40, 50, 60, 90. And so we'd have 15 over 12. So that is greater or equal to 0. Number's bigger than, so we do that. Let's try negative 4. So if we plug in negative 4 on top, negative 4 plus 6 would get us 2. In the denominator, we would have negative 4 squared to get us 16. And negative 5 times negative 4 would get us 20. Minus 24. So that would get us 16 minus 4 would be 12. So 2 over 20 minus 24 minus 4. 12 would be 1/6. And is 1/6 greater or equal to 0? Yes. And then if we plug in negative 7 plus 6, we would get negative 1. Over negative 7 squared is 49. Negative 5 times negative 7 would get us positive 35. Minus 24. So let's see what we get. We would get so in the denominator we would get 38. So is negative 1 over 38 or a negative number greater than or equal to 0? No. So cross that off. So then lastly we can write our answer in interval notation. We look from left to right. So I don't see anything shaded until I hit negative 6. So we do bracket at negative 6 because it's included, comma, we stop at negative 3. Not included is going to be a parenthesis. Union, we do parenthesis where we start at 8. And we're heading to positive infinity. So we're going to do parentheses. So that's our final answer. Okay, try the evens for homework. Remember, 2 periods from now, you're going to have a quiz. So next class period is going to be a study guide, and then the following will be a quiz.